today. I kind of waited a long time, I know I have, but I just want to make sure that everyone who's likely to be here has turned up. I want to do just a little bit about conservative margin of error, just one more kind of finish off thing. And we've pretty much already covered over the last previous 2 days the 2 sections in chapter 5. And I'm glad I did, because someone just turned up. So, conservative margin of error. There are a couple of questions at the end of the first chapter 5 homework that are to do with this. Conservative margin of error. I'll call it CMOE again. And it is 1 over the square root of n times 100%, right? No biggie here. And the kind of questions you get are find the conservative margin of error, create what's called a 95% confidence interval. So that's the first thing. Second kind of question is find 95% confidence interval. And that, in a very generic way, is the percentage of people in your sample who said yes. So you ask them a question like, have you been to France? Are you going to vote for candidate A? So it's the percentage of people who said yes, plus or minus the conservative margin of error. And the third thing is how big the sample needs to be. So hopefully these things are familiar. So I'm just going to do one story basically based on that, just so I'm comfortable that we've covered it in enough detail. So let's suppose that you're interested in the number of people who have been to Scotland. And so you collect a sample, a nice random sample of 2,000, I should say, adult Americans. And the percentage who said, yes, I've been to Scotland was, let's say, 12%. Okay, so that's given to you in the story, right? They conducted a sample of 2,000 adults, American adults, and 12% of them had said they'd been to Scotland. So we're going to use that to make a prediction on what all of American adults have done, right? Kind of ballpark figure for what the answer would be if we did a census and asked all of them. So the conservative margin of error, 1 over the square root of 2,000 times 100 followed by a percent, okay? And in this case, hopefully I can hit the buttons the right way around to change. 1 divided by the square root of 2,000 times the answer by 100. And I'm just going to round it off to 1 decimal place. So that's 2.2%. So if question A had been find the conservative margin of error, the answer would be 2.2%. That's the kind of thing, right, you hear on the TV when they do, you know, polls to do with who's going to be elected. The Conservative guy got 29% and the margin of error was 2.2%, that kind of information. Let's now do part B and find a 95% confidence interval, CI for short. So it's going to be the percentage you said yes, plus or minus the conservative margin of error. So in this story, 12% of the people we asked in our sample, and the margin of error is 2.2%. Now, if you take 12 and add or subtract these, you get your interval. If you take it away, it could be as low as 9.8%. If you add it, it's 14.2. So you could look at that interval and say, we're pretty sure that the entire American population, the percentage of being to Scotland, is somewhere in this range. Do you see we've now got a better idea of what the information looks like? But you get it's a reasonably small interval, so I should feel pretty comfortable about it. And that's what we're after. We want to have a kind of better idea of, couldn't you be 12% and plus or minus 50%, or 12% plus or minus 1%? Wouldn't it make a difference what you thought about the information based on the margin of error, how big it was? So it's important that we know it. Of course, and I keep on having to emphasize this because it's easy for non-statistic people to make a mistake here. This is called a 95% confidence interval because this interval, typically, 95% of the time, this interval contains the right answer. But it also means 5% of the time, this interval is wrong. The real answer could be miles away. And in statistics, you're never, ever going to be 100% sure about anything, except maybe politicians lie, right? But apart from that exception, the rest of the world, there's a bit of, I'm not 100% sure of anything, right? And that's what statistics is referring to. So if I did this, wouldn't 1 in 20 of my polls, that's what 5% is, 1 in 20 of my polls would get it wrong. And what politicians tend to do is they point out the one that's wrong and use that as evidence to prove that the other 19 must also be wrong. Well, if that one's wrong, who's to say this one isn't wrong? You know, the kind of argument. And what they tend to do then is they say, well, I don't believe in polls. You ever heard politicians say that one? Don't they normally only believe in polls if they say things they don't like? But if the poll says you've got a 90% favorability rating, I bet you a darn dollar they'd say, oh, I like that poll. I believe that one, right? Our job's not to put value judgments on it. Our job is to give this data and let other people decide how comfortable you would be using that information and to make decisions. And then C, same story, right? And this time it is, how many people in my sample? Do I need to ask? To get a conservative margin of error of, okay, what kind of percentage do you want? Give me a smaller number than 2.2. I want to be more accurate than that. Give me a smaller number.
0.4.
Right. I want to be, give or take 0.4, right? And now, before I even went and asked the question, we have a formula that will tell us how many people we need to ask to make sure that this is the margin of error that we get. And the formula for that is N 1 over the margin, conservative margin of error squared. But that isn't, if I wanted a margin of error of 2%, I don't put 2 there, right? Isn't the little tweak you have to call it a decimal when you use it in this formula, right? So the margin of error is 0.04, but the number that we use is the decimal version of that. So in this formula, it's 1 over the margin of error written as a decimal squared. And if I do 1 divided by 0.004 squared, I get, 62,500 people. Can you imagine that is a massively big sample? Can you also see why it's very rare that we do samples that big? Bill Gates could probably afford it, but there's very few people who could. Do you know what the normal going rate is? It's about 1,000 and change, about 1,004. That's what Gallup poll do. It's big, but it's not so big that it would cost a fortune, right? Any questions about that? Because that's basically all I wanted to do as far as schoolwork goes. I wanted to just make sure that I'd covered this to the degree that I felt like necessary. Are we good? Any questions?